This is a very good question that goes back to the remainder theorem. So why is synthetic division allowed on the first problem in notes? Well, part of that is just the understanding that in notes we had this polynomial s of t is equal to t cubed minus 8t squared plus 10t. So I could find s of 7 the old-fashioned way. I could say 7 cubed minus 8 times 7 squared plus 10 times 7 if I wanted to substitute 7 in. So 7 cubed is the same thing as 49 times 7. 50 times 7 is 350, so then minus 7 would be 343. Minus, now I have 8 times 7 cubed, 7 to the second power, so this is what 49 times 8 is. Well, that'd be 749s plus another 49. So if I added 49 to this, I would get 392, and I can check that that is true by multiplying, and then plus 70. So then I do this subtraction, and I get negative 49 plus 70, or negative 21. And while it's sure there's some other more clever ways to do this, for instance, if you notice here and here, we could have actually factored the 7 squared out and gotten 7 minus 8. And actually, in all cases, I could have factored a 7 out of the whole thing. But if I factored a 7 out of that and got 7 minus 8 plus 70, then we could have gotten there a lot quicker. But the remainder theorem says that if I take t cubed minus 8t squared plus 10t, and I'm actually trying to, when I plug 7 in, I'm trying to determine if t minus 7 is a factor. And so the remainder theorem says that if it's not a factor, then what's left when I divide is the same as this number. So I'm actually going to show this a little old-fashioned division style. We're going to do plus 0 here. So I'm going to add, I'm going to get a t squared, I get t cubed minus 7t squared minus plus negative t squared plus 10t. Then I subtract a t, multiply negative t squared plus 7t. Then change the signs, add 3t plus 10, multiply, and I get a 3. And I end up with 3t minus 21 minus plus, oh, this shouldn't be plus a 10, that's plus a 0 because that falls down. And I get 21. So I end up getting 21 over t minus 7 as my solution. And that's the tricky part about this, is that this 21 is the same. Oops, actually should have been a minus 21. I didn't do the changing the signs here when I subtracted that. Nope, that 21 was right. This was the one that's wrong. That should be a positive 21. And yes, if I plug in 7 squared here, I get 49, negative 21 plus 70, that's 21. So we end up with 21 here, here, and here. So finally, synthetic division is just a quick way of doing the same long division that we just did right up here. So if I do synthetic division of 1, negative 8, 10, and 0, and I'm going to do it this style, this is just quicker. So 1 times 7 plus negative 8 times 7 plus negative 10, and then 21. I know that 21 is the same thing as if I plugged it in. So my point is that synthetic division can be a lot quicker to take polynomial values and plug it in. And the bottom line is that, let's say I'm trying to define s of 100, or something even crazier like s of 101. Rather than plug it in, you can always just do synthetic division with it, and you'll get exactly the same thing.